Hi guys, in this video we will learn how to find empirical formula and molecular formula. This is very important in the chemistry and these questions always come in the quizzes, in the exams, in the mid exams, final exams. So pay attention because it is very easy. It seems very hard, but it is very easy to find empirical formula or the molecular formula of a compound. So in this question we have the question is determine the empirical formula and molecular formula if 92.32% carbon and 7.68% hydrogen. So and the spectrometer analysis are 26 gram per mole. So there are two things. The one thing we are given is carbon is 92.32% and hydrogen is 7.68%. So that's the two things we are given. This is to calculate the empirical formula. And the third thing we are given analysis is spectrometer is 26 gram per mole. Okay, so for finding the empirical formula we need these two. To finding the molecular formula we need this. So first what we'll do, we're going to discuss these two and we're going to erase this for right now, so we will come back to this one. So I will erase this right now, or I can write down to the side here, right here. I can write down here, I'm sorry, spectrometer analysis. So I will say spectrometer (26 gram per mole). Okay. Alright. Now we're going to come to the first empirical formula. Empirical formula is very easy. So the first step going to be you have a carbon and hydrogen. So first thing, let's remove this percent. So in this kind of question, like when you have to find empirical formula or molecular formula, this percent sign means like their gram. So you can remove this and just write down as a gram. So 92.32 gram, okay, and then 7.68 gram. And we are converting, the first step we will converting this to moles. So whenever we will convert to the moles, what we do, we will multiply and we see 1 mole of carbon divided by this, and then 1 mole of hydrogen divided by this. So what is the 1 mole of carbon? Remember in my previous videos I told you how to convert grams to moles and how to find out how much 1 mole of carbon is, how much 1 mole of hydrogen is, how much 1 mole of nitrogen, how mole anything is in the periodic table. So if you look in the periodic table, the carbon is right here. So the carbon is right here and it's 12.01, and hydrogen is right here is 1.008. Okay, so let's go back to our topic and right here. Right, so carbon is 12.011. So 12.011 gram, and this one is 1.008 gram. Okay, gram and gram cancelled, gram and gram cancelled. Now all you gotta do is just do the regular simply mathematication. So you have to divide 92.32 divided by 12.01. So 92.32 divided by 12.011, you will get 7.68. So you got 7.68, my bad, 68, 7.68, and if you do on the bottom side 7.68 divided by 1.008, you'll get 7.61. So you'll get 7.61. Almost you're getting 7.6. You are getting it. So now at this point, what we will do, the next step is you have to divide it whichever is smaller. So in this, from this, which one is smaller? The smaller one is 7.61. So you will divide with the 7.61. 7.61. So this will cancel with the 1, and this one will be always almost 1. Not it's going to be 0.9999999, but it's almost 1. When you're going to convert it to the whole number, it will be 1, because 7 point right here is 7.61 and this one is 7.68, and they almost equal, they almost 7.6, so they will consume at 1. So we have, so this one was carbon in the beginning and this one was hydrogen. So we have carbon, we have 1, hydrogen we have 1. So how do we write it down? This is, we'll find the empirical formula. So how do we write it down? We're going to write down like this: carbon and hydrogen. We say 1 here, say 1 here. So this is the empirical formula. This is how you find the empirical formula of any compound. C1H1 is the formula for empirical formula for the compound. I will do a recap again. The question was, determine the empirical and molecular formula if 92.32% carbon and 7.6% hydrogen. You have to stop right there. If there's oxygen, you will count oxygen too, but not this thing. For empirical formula, you do not need this. You need this for only molecular formula. Okay, so we have carbon and hydrogen. In this example, we do not have oxygen. Sometimes question will come with the oxygen as well. So for example, the question come with the oxygen, you will also write down CHO. So C1H1 and O probably 1 or either 2 or either 3, whatever O gonna be, depending on how you solve the equation. That's how you're gonna write the O. But in this example, we have a carbon and hydrogen. We do not have oxygen. So we got carbon 92.3%, hydrogen, and we assume this percent is gram. In this kind of questions, ignore this percent as a divided by 100. This percent becomes a gram. So this is grams. So 92.3 carbon we convert into the mole. When we convert into the mole, we divide it by 12, because 1 mole of carbon is equal to 12, is in the periodic table. And then we got 7.68. Then after hydrogen, we have 7.68 is given. We convert into the mole. 1 mole of hydrogen is equal to 1.08008. We got it from the periodic table. Okay, when we divide this with this one, we got 7.61. And so whenever you have, so before we got 7.68 and here we got 7.61. So you will divide whichever is smaller. So 7.61 is smaller and 7.61 is bigger. Even it's a smaller bigger, but this one is still bigger. So you will divide with 7.61. So we divided both term 7.61 and 7.61. This one become direct one, and this one was 0.0. This one was 0.99999, something like that. But when you round it, you got 1.0. So we have 1 and 1. So we got carbon 1, hydrogen 1, and this is our empirical formula, carbon and hydrogen. Okay, so now we got it done, the empirical formula. Now we're going to move on to the molecular formula. Okay, So molecular formula is also a very easy step. It's very easy. I will write down right here. I hope you can see it here. So we have empirical formula is this. Once we got the empirical formula, we will get the formula mass. It's got the molar mass of this compound. I talked about in my previous videos how to find the molar mass of a compound. Any compound you can find a molar mass. So I will do it here again. So we have a C1 and H1. You will find the molar mass of this compound. So first thing you gotta do, you have to isolate it. You have to isolate C and H. So C plus H. Now you have to see the coefficient. Coefficient is 1, 1. You will multiply 1 with C and then hydrogen with 1. So now we're gonna write down 1 multiply C. What is C? C is carbon. How much carbon is? We will go to periodic table. What is the value of the carbon? We have to go to periodic table. We just wrote it down here is 12.01. So 12.011 for the carbon, and the hydrogen is 1.008 multiplied by 1. So we got 12 here plus we got 1 here. So 12 plus 1 is equal to 13. Okay, so our molar mass is equal to 13. For C1H1 the molar mass was 13. So the molecular formula is I'll erase some stuff because I ran out the space. So I'm going to erase the top part. I will erase. So we got the molar mass. So molar mass is this. So we got the molar mass of C1H1. Molar mass was 13. We got 13. Okay, now I'm going to erase this thing and I'm going to find the molecular formula right here. So the molecular formula will be very easy. So once you find the empirical formula, you find the molar mass of the empirical formula, then the molecular formula will be like this. So let's see, the molecular formula is equal to the given value 26 divided by this molar mass 13. So you divide it 2. So you will got 2. So molecular formula you got 2. So what you will do, you multiply this 2 with the empirical formula. So let's see, you have C1H1. Now you're going to multiply with 2 multiply. So it's going to be C1 multiplied by 2 and H1 multiplied by 2. So what you got? You got C2H2. That's your molecular formula. So the molecular formula will be C2H2. Okay, so again, for finding the molecular formula, after you find the empirical formula, you will find the molar mass of the compound, carbon and hydrogen. In this case, we find the molar mass earlier. Is you have to just find a value for the carbon, find the value of the hydrogen from the periodic table, and then multiply with their coefficients and then add them. Once we add this, carbon was 12, hydrogen was 1, so we got 13. And once we find the molar mass for the empirical formula, then we will divide the given spectroanalysis from the molar mass. So 26 divided by 13, we got 2. So this 2 we will multiply this with the empirical formula. So we have a C1H1, we multiply with the 2, 1 multiplied by 2, 1 multiplied by 2, we got C2 and H2. That's our molecular formula. If in case, just for example, if the empirical formula was C2H5, what will be the molecular formula will be? If we have a molecular formula is 2 here, what will be? It will be C4 and H10, because C2 multiplied by 2 and H5 multiplied by 2. So I'm just giving this example. This is not the question. It's just giving example. So the molecular formula, that's how you find it. You just divide this with the molar mass of the compound, and then you got whatever answer you will get. You're just going to divide that answer with the whatever answer you will get, you will multiply the answer with this term, and then you will get C2H2. That's your molecular formula. I hope you like this video, and this is very important in the chemistry. If you have more practice for this one in your homework in the book, you will do it, because this question is always there. It must be sometime it's an extra credit question, it's a quiz question, or anything, but the finding the empirical formula and the molecular formula is the very important question in the college chemistry. I hope you like this video. I hope this helpful you. Please, this is my initial channel, so like it, subscribe it, and share my videos. Thank you very much.